Okay, so in the second part and last part of this video, we're going to be looking at the family of roses. So they're called roses for obvious reasons. They look like flowers, they have petals, and we want to count things like the number of petals. And then we also want to look for symmetries. So we have, to know that something is a rose, it's going to have a leading coefficient, right? But then you'll notice that there's a coefficient for theta, right? So we're going to spend a lot of time looking at this guy right here, and the coefficient to theta, he's actually going to drive the number of petals that we have. So first let's look at sign flowers or sign roses. So a couple of things. First of all, let's look at the symmetries. So you notice that these graphs, like all sign graphs, are symmetric about pi over 2, right? And then the second thing that we want to notice is the number of petals. So this is the big rule. If your n value is even, then the number of petals will be twice your n value, right? So this must be the graph r equals, this looks like 2.5 sine, and then I had 4 petals, so this must have been 2 theta, right? Then if your n value is odd, then the number of petals will be exactly equal to n, right? So this looks like, this must be the graph r equals 2.5 sine, and then I've got exactly 3 petals, so this must have been 3 theta. And then the other thing that we want to notice is that the leading coefficient here and here, that's the petal length, okay? That's the petal length. So when we graph roses for sign, we want to look at the leading coefficient for the petal length, and we want to look at the coefficient for theta for the number of petals. All right, let's take a look at cosines. So very, very similar rules for cosine, right? The only difference is now I'm symmetric about the line theta equals 0, or the polar axis. If the coefficient of theta is even, then I will have twice as many petals as that number, right? So this looks like, this must be r equals 2.5 cosine. Let's count how many petals we have. 1, 2, 3, 4, 5, 6, 7, 8. This must have been 4 theta. I come over here. This time I have an odd number of petals, right? So that means that the leading coefficient was odd. This must be 2.5 cosine. I've got 5 petals, 5 theta. The rules for sines and cosines are the same, right? Noticing again that the leading coefficient 2.5 matches up to the petal length. The only thing that's different between sines and cosines when you make roses are the symmetries, right? So you'll notice that for cosine, your petals are always going to be around the polar axis. It's going to slice this petal in half. That's going to be your first petal right there. Right, there's your first petal. All right, let's take a look at some examples. Use symmetry zeros and the maximum value to graph r equals 2 sine 2 theta. So this is the thing that tells me right away that this is going to be a rose, is that it has a coefficient for theta. So what am I going to be evaluating? So first of all, this has a sine, and therefore it's going to be symmetric with respect to theta equals pi over 2. Second, this is a rose, right? And the coefficient, the leading coefficient of the graph, right here, is going to correspond to the petal length, right? So these two things go together. And then lastly, the coefficient of theta was 2, which is an even number, and so therefore there are going to be 2 times 2, or 4 petals. For sines, one of the easiest things to do to find out where the petals are going to be is you can take pi and you can divide by the number of petals, and that will tell you where the first petal is going to be. So for instance, here it's going to be pi over 4 is where the first petal is going to be. All right, so we've got symmetry with respect to theta equals pi over 2. So I went ahead and graphed that line. And then I'm expecting to have 4 petals, right? And they need to be evenly spaced. And we thought that the first petal was going to be right here at pi over 2, right? So we're expecting to see something that's like this, right? And then remember, these petals have to be symmetric. So if I have a petal here at pi over 4, I'll have another one at 3 pi over 4, right? And then I'll have another one here at 5 pi over 4, and then another one here at 7 pi over 4. That's just the location for where I'm expecting them to be. And then, of course, we need to remember that these petals are only supposed to have a length of 2. I've sort of drawn them oversized. But we can also plot points on our graph to help us find the maximum value, right? There's the maximum value. It occurred at pi over the number of petals for the sign. And what we'll notice about this graph is that it is symmetric about the line theta equals pi over 2. The max values occurs where the petals are, right? Wherever the petals are, which are, let's see here, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then, of course, the zeros occur wherever you graph and you're back here at the pole. And those are going to occur at 0, right? So they occur here, pi over 2, pi, and 3 pi over 2. All right, so here's guided practice number 4. Determine the symmetry, maximum R value of the equation R equals 5 sine 4 theta. Right, so a couple of things. It is a sine, right? So we're paying attention to the fact that it's a sine, which means it should be symmetric about pi over 2. So that rules out B. It's not going to be symmetric to the polar axis. Those are cosines. All right, what else? So we also know that R is going to be equal to 5. Right? So let's look at how many petals we're going to have. So this is a 4, which means we're going to have 8 petals, which means the first petal is going to happen at pi over 8. So that rules out A, and that rules out D, and that makes the answer C. First petal is at pi over 8. All right, last example. Identify the type of curve given by R equals 4 cosine 6 theta. The dead giveaway here should be that you have a coefficient for theta, and that's going to immediately indicate that this guy is, in fact, a rose.